Right, we're going to do a little bit more work on work done and resolving forces. So just bringing those two things together. If you remember from last week, work done is equal to the component of a force in the direction of motion multiplied by the distance moved in the direction of the force. So for this one here, the motion is going to be horizontal, and so we can resolve this pulling force parallel and perpendicular to the plane. The perpendicular component will not affect motion, so we're only interested in the component of the force in the direction of motion. So the work done by this force here, 27 newtons, if this block moves 15 metres, so the work done is equal to 27, and then we want the adjacent side to the angle, so it's 27 cos 25 multiplied by 15, which gives you 367 joules. The component of the force perpendicular to the motion hasn't done any work because there's been no movement vertically at all. Similarly on a slope, so thinking about these forces, I've got 2g coming down, which is the weight. I've got a reaction force. I've got a pulling force. It's going to be moving up the slope. And we can also have a frictional force of 6 newtons. And it moves 12 metres up the slope. So we can talk about the work done against friction. And that is equal to the distance, 12, times this force, which is 6. We can also consider the work done against gravity. In order to do this, we need to find the height that the particle has moved up by. So we've got a right angle triangle here, 30 degrees. The distance is 12, and we're interested in h. So h is equal to 12 sine of 30, because we want the opposite side. So the work done against gravity is equal to 2g, which is coming down this way. So the weight times 12 sine 30. So you can kind of split this into each force and find how much work you've done to oppose these forces. And this one comes out as being 118 joules. So also the work done against gravity is the same as the increase in potential energy, which we'll talk about a bit more in a lesson or two's time. So how far up have we gone against the weight? Okay, if you start by doing exercise 2A, online textbooks, question 8, question 12, question 14, and then I'm going to record another video on coefficient of friction so you can access some more questions on this.